In this tutorial, we'll be discussing the evolution of gas during an acid-base reaction. Some reactions form gas directly from the ion exchange, meaning when we take the inside ions and we put them with the outside ions together, the K is now with the sulfate, so that's a +1 and a -2. Crisscrossing, that's how we got that 2 there. And the outside, or in the inside ion, that's a +1 and a -2, crisscross, and the 2 is there. H2S automatically is a gas, so it's not going to so that's how the gas is going to be created. Other reactions form a gas by the decomposition of one of the ion exchange products. So for here, SO3 is with H, and K is with sulfate. So K2, that 2 came from the -2 here. And hydrogen sulfide, 2-, sulfurous acid. And then we break this down to form H2O and SO2. And that SO2 is the gas. So the gas is then formed directly from the inside-outside, from the double replacement. It's formed after the decomposition of the next step. So here's another example. Sodium bicarbonate with hydrochloric acid. Inside ions, outside ions. NaCl. And then this actually forms H2CO3. And then it further breaks down to H2O and CO2. Now what's happening in these beakers here, notice that there's a lot of foam being given off. Sodium bicarbonate, the sodium ions are floating in the solution, and then we have the bicarbonate solution just floating around. HCl, the chlorine is floating around. The hydrogen of the HCl has attached itself to the water, so it's H3O now. And then once it gets mixed together, that H3O here and an OH group from here is going to form, these two things are going to come together to form the H2CO3, and then that's going to break down to the water and the carbon dioxide, and the sodium chloride is just floating there. So how do you know about the gas evolution, what you should look for? Well, if you look for a single anion of sulfur, it's going to form a gas on its own. It doesn't need to decompose. However, if you see the polyatomic ions for carbonate, bicarbonate, sulfite, or hydrogen sulfide, or ammonium, that's actually going to break down further to form CO2, SO2, and NH3. So let's take a second to practice this. When an aqueous solution of sodium carbonate, so NaCO3, Na is a plus, CO3 is a 2-, so it's Na2CO3, is added to an aqueous solution of nitric acid as HNO3, nitrate is a -1, so we only need 1 there, a gas evolves. Write the chemical equation. The very first thing you ever want to do with these is the inside-outside. So the Na is now with the NO3. Na is a +1, NO3 is a -1, so it's Na1, NO3. And then the H is now with the carbonate. H is a +1, CO3 is a -2, so it's H2CO3. It might help to balance it at this point, so that way we know where our atoms are before we start breaking things down further. So nitrates are balanced. Sodiums are not. We have 2 sodiums here. We need 2 on this side. This means we now have 2 nitrates. So now let's see, we have 2 hydrogens, 1 carbonate, and 1 carbonate. So we can move on. So we're going to carry over our balance equations. So that means we have 2 2HNO3 and 2NaNO3. Check to see if either product is H2S. And sulfur wasn't even in this compound, in this reaction, so we can bypass that one. Check to see if either product decomposes to the previous question. So, H2CO3, it has that carbonate, so it's going to decompose. So H2CO3 is going to decompose to H2O and CO2. Now, the reason why I wanted to balance it before I went about doing this, even though this is the true final product, by balancing it first, I was able to balance it easier because of the carbonates. Because now that the carbonate has broken down, it's a little bit more difficult because you have to keep track of more atoms. However, if we balance from left to right here, 2 hydrogen, 1 carbon, 3 oxygen. So the actual balanced amount does not change. Alright, determine the solubility of the other product. So we know this turns into H2O and CO2. We know it's 2NaNO3 and 2HNO3. And we're looking for the solubility of this. Sodium is an alkali metal and it's aqueous, and so is nitrate for that matter. So both of those are aqueous. So write the sulfur solid after the insoluble product and an aqueous after the soluble products. Balance the equation. Because we balanced it at first, we're already done. So the actual balanced equation will then be Na2CO3 aqueous plus 2NO3 aqueous yields 2NaNO3 aqueous plus H2O liquid plus CO2 gas. Alright, so let's try this again. HCl and Na2SO3. First thing we want to do is the inside-outside. So we have NaCl and HSO3. Na is a plus 1, Cl is a minus 1, so it's 1 and 1, so those cancel. H is a plus 1, SO3 is a minus 2, so it becomes H2SO3. Let's take a second to make sure everything's balanced before we continue, because it'll make our lives easier in the future. 2 sodiums, that changes the amount of chlorines. That changes the amount of hydrogens to 2, which balances that 2 out. So we're good. The next step, see if we have sulfur. We have sulfur, but it's part of a polyatomic ion, so it's not going to produce H2S. See if one of them decomposes. This one decomposes to H2O and SO2. Notice the amount of atoms are still the same. 2 hydrogens, 3 oxygens, and 1 sulfur. Figure out if NaCl, the other product, is soluble. And it is, so that's going to be aqueous. So now we can write and balance the whole thing. 2HCl aqueous plus Na2 SO3 aqueous yields 2 NaCl aqueous plus H2O liquid plus SO2 gas. Let's do one more practice. First thing you want to do, insides, outsides. Alright, so H is now with sulfur, plus 1, minus 2, H2S. And in the insides are Ca and SO4. Ca is a 2 plus, SO4 is a 2 minus, they cancel each other out. Next thing is to balance. This is actually already balanced, so that makes our lives easier. Then the next thing we want to do is make sure that H2S is not one of the products, which actually it is, which means this is going to be our gas. The next thing is to check the solubility of CaSO4. This is actually insoluble, which is making this a solid. And you can check that by looking at the solubility rules. So the final product is H2SO4 aqueous plus CaS aqueous yields H2S gas and CaSO4 solid.